Hey everybody, and welcome to the Cumulative Review Packet number 2, video number 3, where we're starting with number 11, which is a topic from your first cumulative test. Write the quadratic function in vertex form. State the vertex and all intercepts x and y. So first, I want to remind you that vertex form is y equals a x minus h squared plus k. So my idea here is to get from standard form of a quadratic to vertex form, so we can clearly see what the vertex is and can find the x and y intercepts. So in order to do so, the first thing I need to do is start the process for completing the square, because we want this to go from no parentheses to creating parentheses, and one way to do that is to complete the square. Now, in order to do that, though, we can't have a lead coefficient of 1, so we'd have to divide every single thing by 2, including the y value. So we'd have f of x over 2 equals x squared minus 8x plus 15/2. Now, in order to complete the square, your x squared minus 8x needs to be alone. So we need to subtract the 15/2 to the other side, and if we do that, we get f of x over 2 minus 15/2 equals x squared minus 8x. And if we were to actually complete the square, we'd have to add that special plus blank on both sides of your equation. To get that special number, we take our b term, divide it by 2, and square it. So that's negative 4 squared, which is a positive 16 on both sides. The reason we do that, and the reason it's called complete the square, is because this number will always be a perfect square, and it should factor into two parentheses. The two parentheses are the same thing. So this would be x minus 4 quantity squared. So the two numbers that multiply to be 16 and combine to be negative 8 is negative 4. Now over here, though, we need the 16 to combine with the negative 15/2. So to do that, let's think of this as negative 16 over 1, and we need to make this have a denominator of 2. So we need to multiply top and bottom by 2 over 2. So what we really have is f of x over 2. Let's leave that alone, but let's change this to be 32/2 minus 15/2. So that would be f of x over 2 plus 17/2 equals x minus 4 quantity squared. If my goal is to get f of x back alone again, what I would do is move the 17/2 back over. So I'd have f of x over 2 equals x minus 4 quantity squared minus 17/2. To get f of x alone, I would need to multiply every term by 2, so these would cancel, and so would this. So my final answer in vertex form would be f of x equals 2 times x minus 4 quantity squared minus 17. And now that I look at my function, my vertex would be, inside the parentheses is always the opposite sign, so the vertex would be 4, negative 17. To find my x-intercepts, what I'm going to do is set this vertex form I just had equal to 0, because y is 0, so f of x equals 2 times x minus 4 quantity squared minus 17. And if I want to solve for x, I'm going to add the 17 to the other side, and I'm going to divide by 2. So I have x minus 4 quantity squared equals 17/2. If I then take the square root of both sides and I switch the order a bit, I would have x minus 4 equals plus or minus the square root of 17 over 2. Now, what we're going to have to do is rationalize this if we want to keep our answer exact. Think of this as root 17 over root 2. And as you know from semester 1, we can't have radicals in the denominator. So if we rationalize that, we'd have x minus 4 equals plus or minus root 17 times root 2 is root 34. Root 2 times root 2 is 2. So again, sorry about my work. I'm trying to be as neat as I can here. My final answer exact would be x equals, add the 4 over 4 plus or minus root 34 over 2. So my x-intercepts would be 4 plus root 34 over 2, comma 0, and 4 minus root 34 over 2, comma 0. My y-intercept is much faster. What you could do is either look at the original equation here or look at the one you just found, and your goal is to remember that the y-intercept is when you plug x equal to 0. So here's the answer we got in vertex form. F of x equals 2 times x minus 4 squared minus 17. If I plug 0 in here, I would have 2 times 0 minus 4 squared minus 17, which is 2 times negative 4 squared minus 17. 2 times 16 minus 17, which is 32 minus 17, which gives me an answer of 15. So my y-intercept is 0, 15. And if I look back up at the original problem, here, if I had plugged in 0 here and here instead, I would have more quickly gotten that the y-intercept was 0, 15. But I thought I'd do it both ways so you can see that no matter which way you view it, you should get the same answer. And feel free to use your calculator on this if you graph your function. And if you want to look at your graph and see if it crosses the x-axis here and here, feel free to do so. Remember that 4 plus root 34 over 2 and 4 minus root 34 over 2 are just decimal answers as well, so you can check your work. Last problem, back again from Unit 2. Keep bringing back the transformations because we know they're going to help you in future classes as well. Given the graph of f of x here in blue, apply the transformations to this function. Now, what I'm going to do is remind those. I know the ones in my class, we've been using points a lot to use these transformations. It's up to you if you're not familiar with this method, if you want to do it or not. So what I want you to think about is if you look at this new function h of x, what do we have to do to this function to get my final answer over here? Well, first thing I'm going to do is look at my graph, and I'm going to mark down what nice points that I see that I'm going to use. So those points are, I'm going to write them down here, -2, -2, -1, 2, 1, -1, and then 2, 3. And so these represent my original points. And so if I look at my function, remember you have to use the order of operations, work inside out. So the first thing this function is going to do is we are going to go to the right 3 units. And then, after parentheses, we're going to do multiplication before subtraction. So this 1/2 is really a vertical shrink. But what we're really doing is multiplying the y values by 1/2. And then the last thing we're doing is the -1, which means that we're going down 1 unit. And so we're going to base everything based on these points here. So if I'm going right 3, the only thing that I'm affecting is my x value, not my y. So this first point, without graphing anything yet, this first point, if I go right 3, -2 plus 3 is 1, and the y doesn't change. -1 plus 3 is 2, and the y does not change, still times +2. 1 moved to the right 3 is 4, -1. 2 moved to the right 3 is 5, the y doesn't change of 3. The next thing I'm going to do is multiply all my y values by 1/2 to represent my vertical shrink. So this would become 1, that stays the same, divide this in half, 2, divide the y value in half, 4, -1/2, and 5, 3/2, which is really 1.5. Last but not least, moving down 1, again affects the y values, not the x's. So the x's all stay the same. So we'd still have 1, 2, 4, and 5 here. But my y values would become, down 1 would be 1, -2 is my final point. Move down 1 would be 2, 0. Move down 1, -1/2 minus 1 is -1.5. And then 3/2 is really 1.5. So 1.5 minus 1 would be 1/2 or 1.5. So if I graph these final points, that would be my image after all the transformations. So that would be at 1, -2, 2, 0, 4, -1.5, 1, 2, 3, 4, down 1.5, and then 5, 1/2. So my graph looks like it was shifted to the right 3. It was shifted a little bit down, but also there was a vertical shrink. So the graph looked taller originally, and it was shrunk down, which makes sense with this vocabulary. All right, guys, that's the end of the cumulative review packet number 2 videos. If you want to go back and rewatch any example, you're more than welcome to do so. Remember, there is a blank copy of the review packet on Schoology also. Feel free to print that out and try again any problems that you need. Good luck studying, and thank you.